Hello, my name is Aleksandra Miletic and I will present you results of my STSM validation of activity of prepared biopolymer-based nanofibers containing plant essential oils. My home institution is Faculty of Technology Novi Sad, Serbia, where I am PhD student at Department of Materials Engineering. I spent 34 days at IRTA Institute in Monez, Spain, under the supervision of Dr. Begonia Marcos. During this period of time, I performed shelf life study of dry cured sausage packed in active packaging. My work was divided into three parts. In the first part, I prepared and characterized active packaging materials. In the second part, I did a shelf life study of dry cured sausage. And in the third part, I did the characterization of used active packaging materials. All active packaging materials were prepared using electrospinning technique, and they were made from PLA with addition of four different essential oils. The concentration of essential oils was blocked at 10% because we did some preliminary test of antioxidant activity, and we considered that the 10% is the optimal concentration for the best antioxidant activity of nanofibers. Nanofibers were characterized first for morphology, and as it can be seen, very regular and straight nanofibers were obtained without any drops or beads in morphology. This means that electrospinning processing parameters were well established, and also that PLA and essential oil mixture was homogeneous. After that, FCIR analysis was performed in order to see if there is some chemical changes of PLA when mixed with essential oil, and we concluded that as we cannot see any differences between spectra, that there is no chemical reaction between PLA and essential oil, and also we can consider that the whole amount of essential oil was entrapped into the PLA nanofibers. Using DSC analysis, we examined thermal properties of prepared active packaging materials, and as expected, essential oils act as plasticizers on thermal properties of PLA, and as it can be seen, glass transition temperatures and crystallization temperatures decrease with the addition of essential oils, while melting points remain mostly the same, except for the time loaded PLA nanofibers. When finished with the preparation of active packaging materials, we go to further step in the experiment, and for packaging of dry cured slices of sausage, and we perform the packaging by using normally polyethylene polyamide bags. And we put interleavers from our active packaging materials inside, and also one slice on it, and packed everything into the vacuum atmosphere. And also what we did, we simulate the conditions in the store, so 12 hours on light and 20 hours in dark. In the cold chamber, we keep our samples just like that. For our experiment, we prepared 6 batches of samples. One was without fibers, the second one was with pure PLA fibers without essential oil, and 4 of them were loaded with essential oils. For each batch, 3 slices were prepared for each sampling time. Sampling times were time 0, so the first day, then day 7, day 14, day 21, and then day 28. And in that time, we observed the changes on the slices of dry cured sausage regarding color, T-bars, and also the oxygen rate in packaging. When speaking about oxygen rate and changes during time, first, oxygen concentration in the packaging decreased until the day 21 in all packagings which consist also the interleavers. This can be connected to the microbial growth of microorganisms present in the packaging. And after that, there is slight increase of the oxygen concentration in the packaging, which can be connected to the permeability of polyethylene polyamide bag, which is not 100% barrier. The change in color from day 0 to day 28 was visible, and first changes occurred on the borders of slices and goes to the middle of slices. Also, the color change occurred from red color of meat to some slightly brownish color. So we assume that this color change is not due to oxidation, but due to water loss from slices. After each sampling day, we collected used interleavers and used them for further examination of material properties. As it can be seen with a simple visual inspection, that on the material there is a trace of contact with product with slice of dry cured sausage. After the use, the morphology of the fibers didn't change, so fibers remained smooth and regular shaped. But what occurred is a liquid substance that penetrates in between nanofibers, so penetrates into the pores of nanofibers and remain there after the use. When comparing thermal properties of used and non-used nanofibers, we can see that those ones that were used for 28 days have slightly higher crystallization temperatures, but at the same time the enthalpy of crystallization decreased, and also glass transition temperature was a few Celsius degrees higher when compared to pure PLA fibers or PLA fibers loaded with essential oil on day 0. This can be explained that changes occurred due to immiscibility of PLA and liquid substance present in the pores of nanofibers. FTIR spectra was done on samples that were used for 7, 14, 21, and 28 days, and on these used samples, on spectra of these used samples, some peaks on 2900 occurred, which were not present on the PLA with essential oils spectra of nanofibers, and for this reason we want to examine further what happened with nanofibers. In order to see what makes changes in peaks on used active packaging materials, we washed them with ethanol and leave ethanol to evaporate, and after that there was some fatty substance remained after the evaporation of ethanol, and we repeated the FTIR analysis on that one and obtained spectra like this. After further examination and also comparison between the literature data, we consider that this is the typical spectra for pork fat, which means that pork fat from samples penetrates into the fiber morphology. Also, what was done was water activity of samples, so on day 0 and day 28, and it was observed that there is some water loss of samples, so from day 0 to 28. So we proved that the color change is due to water loss, not to oxidation, but samples were losing fat as well. These kind of porous interleavers can induce unwanted effect of dehydration of the products, so they can be used for packaging of the products where water is not desired, for example fresh meat or dried fruits. And as there is no chemical change of PLA-based material during the time, which indicates that there is no degradation of the material, these kind of materials can be considered for long-term use. At the end, I would like to thank to Cost Action Act Impact for supporting my STSM, and also I would like to thank to my great host, Dr. Begonia Marcos, from who I learned a lot during my stay in Girona.